Yeah, we'll do it after. Yeah, it looks like we have a quiz on Monday. Anyway, the quizzes are going to be Monday and Wednesday, tests is on Friday.
So many quizzes.
Anyway, so this quiz should be easy because it's only going to be on expo log 1. She was here this morning. Where'd she go? Okay, I'm thinking last night's homework was so easy we don't need to go over anything.
Again, you. Oh.
What? Okay, wait. Everybody back up 1 foot. You guys are too close to the front. Okay, this is how it's supposed to be. The front of the first row should be like right here. 1 E and 1 E. Who? I want to know right now. Who wrote 1 E? Oh, was that you? 1 E. Was that you, Kellen? Did I or did I not show this example yesterday? 3 to the x plus 3 to the negative x equals 10/3. Did I or did I not do this as an example yesterday?
You did.
And is there an example just like that in the examples? And okay, let me write down 1e. 2 to the x plus 2 to the negative x equals 5 halves. That looks so much different.
But wouldn't she have to because there's only like one on the board?
No!
You have to multiply by 2 to substitute.
Where did you come from? And back up. You're giving me the willies. Back up. So I'm not going to do 1e on the board. Refer to the video or the example on the back of the notes. Oh my goodness. That's a joke. I believe. I hope it's a joke. Okay, this one we're going to be doing synthetic division, right? See, but the problem is, it's not really a problem right here, because if you just have 2 to the 3x, then you can just let u equal 2 to the x, right? And that would become u cubed. But what do we do with that? Well, isn't 2 to the 3x plus 2 the same thing as 2 to the 3x times 2 to the 2, because then you would add the exponents? But 2 to the 2 is just 4, so this is the same thing as 4 times 2 to the 3x. And then now, if you let u equal 2 to the x, this becomes 4u cubed minus 37u squared plus 41u minus 8 equals 0. See, this is just an extension of what we did over here, right? See how you gotta keep pushing forward? And then how do you factor when it's third power or higher?
Synthetic division.
Okay, so 4, negative 37, 41, negative 8.
1.
Can you see that 1 works?
1.
Or negative 30, negative 33, 8, 8, 0. So this factors as u minus 1. It's minus now. Some people still, they put 1 in the box, they put u plus 1. And then 4u squared minus 33u plus 8 equals 0. And then that factors even more. So what does that come out to? 4u, u, 8, 1, minus, minus. So u equals 1, 1/4, or 8. Fox said that's the answer.
No.
No, your substitution was 2 to the x equals u. So now, 2 to the what power equals 1?
0.
2 to the what power equals 1/4?
Negative
2 to the what power equal 8?
3.
There you go. I think we'll be seeing this one on Monday's quiz. Number 2, A or B? That's not funny. These are easier than the example we did yesterday. Okay, Karen's, okay, you're gonna have 5 problems on the quiz. Okay, that's gonna be 1F, and then number 2, that's definitely one of them there.
There's just 3 to be your A.
Okay, which one you wanna do? Pick one.
Motion's
I don't know, they both look
B.
easy to me.
Hey.
B.
A, B.
Hey, these numbers look like the one from yesterday. What? I didn't do any examples yesterday. I just handed this out and said, okay, start your homework.
We weren't here yesterday.
I'm gonna lecture on
Touche.
When I mean yesterday, I mean the last class.
I don't remember that.
And that's the problem, people. Wait till you see the one I got for the test. Might not even have numbers.
Why would you do that?
To see if you know what you're doing. You gotta keep pushing forward. Okay, what can I factor out? First of all, the number, I see a 2, right? 2 and 6. And when you have a fraction, you gotta factor out the least common denominator. And what do I factor out with x and x squared?
S.
And then what about 6x plus 5 to the something and 6x plus 5 to that something? You factor out
The negative 4.
the smaller one. So this needs to be factored out. Did everybody get that?
Yeah.
Or are you just writing it down now?
Why did I do that? Distribution.
So why do you do the thing?
What thing?
Oh, why didn't you just take out 2?
Because if you have 2 and 6, you factor out a 2, right?
But you have the 1/3.
Yeah, so you factor out the least common denominator. What's the least common denominator of 1 and 3?
Well, so you can't just multiply the other side off. You take out.
Oh, I see what you're doing. Okay.
What?
He's saying, why don't you just go 1/3 times 6 is 2? Okay, then in that case, we don't have to factor out the 1/3. But then, what happens if this number on Monday is like 7? Then you
Oh,
can't.
then you have to do it.
Yeah, thank you. Okay, I didn't even notice that, but this would have worked out anyway later. Okay, so here we go. If I factor this out from that, what's gonna be left? 6x plus 5 to the, no, to the 1. Because this times this gotta give you this. When you multiply this times this, you add the exponents to get that, right? So negative 4/3 plus what will give you negative 1/3? 1. Let's see what happens on one. Minus, I factored out the 2, and there's an x, so there's just gonna be x. And that's it. Everything else is there. So if you simplify what's in the brackets, you're gonna get 5x plus 5, but then you can factor out a 5. So your final answer is gonna be 10x, 6x plus 5 to the negative 4/3 times x plus 1. You have to completely factor. You guys gotta practice. But no, I think I get them on Monday, Mr. Park. Yes,
Why is it minus x? Where do you get,
because there's a minus sign.
where do you get the x from?
Because you factored out an x, and that's an x squared.
Oh,
If you were to distribute it, you get the original problem, right?
Whoa, why isn't it? Just
Why do they do that? It's like-
Why do we factor? I told you, because in calculus, you're gonna do this, and you have to know when this thing is positive and when it's negative. So you have to make a number line, but in order to make a number line, it has to be all factored.
here.
Okay.
Otherwise, if we didn't do this in calculus, we wouldn't even be doing this now. Yeah.
Okay, so I get the 6x plus 5, but for the negative x, when you like, if you distribute it, wouldn't you get an x squared?
Yeah, there's an x times x equals x squared.
Yeah, but then when you distribute the other one, you get another x squared. 6x plus 5, then negative 4/3 times negative x, and you're like 6x squared. But you're distributing everything to the negative x, right?
Yeah, this times that.
Yeah, so negative 2x times 6x.
When you multiply this times x, all that happens is the x gets squared. You're multiplying, you're not, I don't know what you're doing. You're multiplying. Oh, so you're telling me this then, this is what you're telling me. If I multiply 2 times 3 times 4, I have to distribute the 2. So it's actually 6 times 8 then. No, it's not. It's not. That's what he's saying. It's times. You don't. This is algebra 1.
You can't say stuff like that.
I can't what? I can't say stuff like what?
Like that.
Like this is algebra 1?
Yeah.
But it is algebra 1. You add the exponents.
My life's so high.
Okay, now we're on to number 2. Well, we did 2, and then number 5. Yeah. Okay, number 5. Given the graph of y equals 2 to the x, show that translating the graph 1 unit to the left is the same as stretching it vertically by a factor of 2. What does it say on the bottom? Duh. Does it say duh? It should say duh on the bottom. Okay, how do you shift the graph 1 to the left? You substitute x plus 1 for x. How do you stretch the graph vertically by a factor of 2? Don't you just multiply it by 2? Show that these two are the same thing. There it is. Duh. Duh. Because this is like 1, then you add the exponents. It's duh. Isn't that kind of interesting? Here. Here's the graph of 2 to the x. If you shifted it 1 to the left, that's the same thing as stretching it vertically by a factor of 2. Isn't that kind of amazing?
Wouldn't make sense. Like mathematically it makes sense, but like
Okay, try it visually. No, try an actual graph and show.
I'm not a good drawer.
How about do it on your calculator though?
Better than
Hey, look, wait, it's duh! It's duh!
Yeah, no, I get that part, I get that part.
Okay. Okay, so if the quiz is only going to be on, maybe we should have a quiz Tuesday and Wednesday,
No.
and not.
No, what? No, I'm gonna take
This is not enough material.
I'm gonna take this test on Wednesday.
I don't want it Monday.
Hey, that's your problem. If you're going to miss a whole week of school, that's your problem.
We have more stuff to cover. Good.
I changed my mind. The quiz is on Tuesday.
Oh, okay. Oh, that's better. Okay.
No, it's just-
As long as it's not on Wednesday.
This is too little bit material. We got to have more material. We got to have meat. So number 3.
I was really confused because I went through the
Okay, number 3. The half-life of a radioactive isotope is 5 days. So y equal y naught 1/2 to the t over 5. And first you got to be able to write that. Oh, you did that.
Yeah, I just didn't know what to do after that.
Well, if there are 8 grams initially, where do I plug in the 8 there?
Why not?
Okay. How many grams will there be after 12 days? Where do I plug in the 12?
With the teeth? Wait, but I did that.
That's the answer. That's the answer right there.
Oh,
Just punch it in with your calculator.
I wasn't thinking that. Because that's like, oh wait. I
Okay,
did
if you
it.
punch this in on your calculator, you're going to have to go 8 times 0.5 raised to the 12 over 5
Can
power.
I just do 4 raised to the 12 over 5?
Why no?
Does that work or no?
It's called the order of operations. You raise to an exponent first before you multiply. Please excuse my dear Aunt Sally.
Hey, we learned that.
Oh, okay.
Exponentiation comes before multiplication and division.
Sorry.
Love, this better be good.
Is the H in Kosh?
Hyperbolic.
Yeah, okay. Wait, what's Kosh? Kosh.
Obviously, we didn't look at tonight's homework.
Okay, good.
Okay, tonight's homework, you have to graph some functions that you've never seen before. The hyperbolic cosine and the hyperbolic sine function.
And what is catenary?
You gotta be joking me.
Catenary? Catenary.
I'm not gonna discuss that till Monday. Okay, well, if you look at tonight's homework, we have to understand what this number E is. What the heck is E?
The thing
Now, I
is-
know you guys learned E last year because Mr. Rubach and Mr. Takayasu said they drilled it into you.
No.
What is this number E? Well, it's the limit as n approaches infinity of 1 plus 1 over n to the nth power. This is an expression that comes up very often in mathematics.
So n
Now you guys know what limit means, right? The limit as n approaches infinity, that means as n gets bigger and bigger and bigger, you plug in bigger and bigger numbers for n, like a million, a billion, a trillion. This expression here gets closer and closer to some number. That number is called e. Okay, I'm going to show you. I'm sure you did this last year, but we're going to do it again. Take out your calculator. You guys need to keep doing this. Like some of you probably forgot how to make tables. Remember we made tables a couple of chapters ago? What's a table? You have to keep doing it. See, next semester, we're just going to do it right on our iPad, pad, right? Doom. Next semester.
I have a mini iPad now. You don't own an iPhone?
I have no idea. I don't even know what, I don't know how those things work. We have any seniors in here? Okay, then no problem then, yeah. Because the seniors won't have, yeah. So I'll just say, take out your iPad. The rest of you take out your graphic calculator. Okay, so you go y1 equals 1 plus 1 over x raised to the x power. Okay, that's this expression here. And we're going to tell our calculator to plug in bigger and bigger numbers for x and show it to me in a table. Okay, so the first step is you got to punch this in as a function. I think on the Prism, you guys got to go to the, you guys have to punch this in first or you go to the table first? Isn't there a table thing?
Yeah.
Okay, go to that first and then click.
Oh, I remember that.
Is that right?
Is
Error.
it the opposite
Not
of
like-
exponential graph?
I'm not asking you to graph it.
Oh.
Well, Mr. Park, the first you say error.
We're gonna look at the values in a table. Okay, now before you even go to the table, you have to set the table, both in the Prism and the TI. Okay, so go into table, table set. What does it say?
Error.
Table start. No, it does not say error. Table start means what is the first number I want to plug in for x? I don't know. Let's do tens. It's up to you. And then delta table means what increments do you want to go in? Let's go in increments of 10. Okay, so now when you press your table button, you should see this: 10, 20, 30, 40, 50, and then it's
Error.
All these numbers are the same.
what n? There's x here.
No,
It's
end.
x.
End. Like what you end at.
Yeah.
Oh, in your Prism, you can type in infinity. Type in a million then.
Mr. Park.
Where do we start it?
All these numbers.
Wait, let me look. Wait, let me look. Yeah.
All these,
What's happening today?
all these numbers are the same.
It's such a good.
Oh gosh. I want to choke. I want to choke. Okay, so what's going to happen is your calculator is going to plug 10 into this formula and it's going to spit out the answer. Then it's going to take 20 and plug it into that formula and spit out the answer. Spit, spit, spit. Ka-two, ka-two, ka-two.
Isn't it error? I got error.
How you get error? Okay, let me see your y equal. Okay, there you go. You gotta put parentheses because otherwise your calculator is going to do order of operations.
I hate this so much.
Anyway, look. Every time, the first thing I ask you, did you punch it in exactly as I did? And of course, the answer is no.
So sorry.
Okay, now to answer Lum's question. Lum said, Mr. Park, all the numbers are the same after a while. That's because the thing is only showing you like 3 decimal places in the table.
Even the ones on the left.
What if you want to see more decimal places? Then take your cursor and put it over here. Put your cursor over here, and then on the bottom it's going to show you all the decimal places that your calculator can handle, which is like 8.
Are you getting like 2.5?
There.
These ones are the same.
Yeah, but that's because it's only showing 3. I can feel my blood pressure medicine wearing off quickly. So did you guys put it here? Put the cursor here, and then just scroll down. So you scroll down. Hey, Mr. Park, the numbers are getting closer and closer to something. Yeah, and you know what that something is? E. It's E. E, as we know from last year, is approximately 2.7. 182818284599045, right? These are the 15 decimal places of E, which are in your notes, and you might be wondering why I wrote it there, is because you're going to need to know all 15 decimal places. Because one of the problems on the test, I'm going to tell you right now, it's going to say, round your answer to 15 decimal places. So if you don't know the 15 decimal places, then you're gonna get it wrong. How are we expected to memorize them, Mr. Park? Because there's a story that goes with it. Didn't your teachers teach you last year?
Wait,
How did Nakayama know it then?
Nakayama?
He knew it.
You learned it in Japan.
He learned it in Japan. So you think Japanese education is better than American education?
Yes.
No, I think it is. I think they go to school 6 days a week.
No, they do, they have to.
They have, like,
rest
Yeah,
them
that's why.
because they-
I think we should have a longer school year also. I think we should just do away with summer school and just go 11 months. That's what I think. But that's not gonna happen.
Yeah.
Because we don't care if Japan is better than us.
We don't?
No.
Those are better.
Okay, are you ready to learn the 15 decimal places or you just memorize them on your own? Okay, I'll teach you. All you gotta know is a little bit of US history and you can do this. Okay, you just gotta know the 2. Everybody knows E is 2 point something, right? You just can't remember the rest. Why are you laughing?
I feel like you're gonna do that for every single one, like everyone knows it's
Okay, somebody please tell me the 7th president of the United States.
Jackson.
Andrew Jackson. Very good. He's the 7th president of the United States. He served 2 consecutive terms beginning in 1828. See, 1828, 1828. Isn't that true, Lee? Yeah, okay, see? His favorite triangle, the 45, 90, 45 triangle. And that's how you memorize 50 decimal places of E.
What's the 2 again?
You just gotta know the 2.
Oh, no, but.
If you don't know E is 2 point something, you're too bad.
He served 2 consecutive terms.
Oh, okay.
Oh,
8 to 7.
but
Wait,
they weren't
who
at
was
the same
this?
time.
Andrew Jackson.
Wait,
Served 2
You have to find.
The guy on the $20 bill. I think.
Yeah.
It is, yeah.
Yeah.
Is he also on the $2 bill?
Oh, you can remember because 2 is in 20. This is on the 20.
Is he on the $2 bill?
And the little decimal could be like a small little
Is he on
circle.
the $2 bill?
I could see.
Okay, whatever. Andrew Jackson is on the $20 bill. He was the 7th. I like that. I'm going to use it for now. He's the 7th president of the United States. He served 2 consecutive terms beginning in 1828. His favorite triangle is the right isosceles triangle. 45, 90, 45. Okay, now you see this formula, the limit as n approaches infinity of 1 plus 1 over n to the n is equal to e? That is just a specific case of a more general formula, which is this. The limit as n approaches infinity of 1 plus x over n to the n is e to the x power. This is the one you gotta know. Okay, do you see how this is a special case of when x is what? 1. That's why the answer is e to the 1. Okay, I'm going to give you an easy example, and then I'm going to give you a not so easy example. Okay, limit n approaches infinity. On Tuesday's quiz, this is going to be one of the problems. What is n minus 2 over n to the nth power? Anybody? Okay, this is what we just
E to
learned.
the n minus 2.
This is what we just learned.
E
How
to
can
the
I make this look like that?
E to the
Yeah,
negative 2.
Okay, some of you are getting it, others of you are just befuddled. You have to make it look like this. 1 plus box over n to the n. If you take the limit as n approaches infinity, the answer is e to the box.
So E to the
Okay, so how can I massage this? How can I low-me this to make it look like that? Well, what did we learn in Algebra 1? When you have a plus b over c, what can you do?
AC over
Yeah, you lift and separate, right? Into 2 separate terms, like that. So if you do that here, n over n is 1 minus 2 over n. But since you have a plus sign there, you put a plus sign and you put the negative over there. And now you have 1 plus box over n to the n. If you take the limit as n approaches infinity, the answer is e to the box. Whatever number is here, that's the power of e. N is an independent variable.
Yeah, so like is
Could
it
be
like
any
E
number.
is Y and N is X?
No. This just means when you plug in bigger and bigger numbers for n, this expression gets closer and closer to e to the negative 2.
Oh, like if you're graphing it, and it would be X, and E would be Y.
No, n would be the x. And this here would be the y. No, you said e would be the y.
Alright.
That's
Oh, wait, no, yeah, you would be the y, right?
No, that's e to the negative 2. E is not the same as e to the negative 2.
Wait, say.
E is not the same as e to the negative 2.
So show me why. If you go.
Because e is not the same thing as 1 over e squared.
You're grabbing it, which one would be y?
This is the y. The whole thing is the y coordinate.
So what's the x?
N.
Oh, okay.
Okay, can we follow the easy one now? Let's do a harder one. You guys think you're good, yeah?
No.
What's the limit as n approaches infinity of n over n plus 1 to the n? Now, when you go to BC Calculus next year, you're going to see this one a lot.
E to the n.
No.
What? No, come on.
Okay, what you have to do is you have to make this look like this. You have to make it look like 1 plus something over n to the n power. So can I just separate it into two separate terms here? No.
Oh.
So what do you do then? What do you do? How are you going to lift and separate? You got to flip it over. You got to hoolie it. You got to hoolie before you load me. Yeah, then you put negative n.
Yeah.
You hoolie. Everybody understand?
Yeah.
You hoolie it. But then you got to put negative n power there. Now you can lift and separate, right? So n over n is 1. 1 over n. Hey, it's starting to look like that, Mr. Park. Yeah. Yeah, but Mr. Park, it says n power. So that this is where you got to loam it. You got to massage it. Massage. Everybody see what I did? I just put the negative on here. Because then you multiply the exponents, right? This is called lomi, massaging. So look at the thing in the brackets. 1 plus box over n to the n. If I take the limit as n approaches infinity, the thing in the brackets gets closer and closer to what? E to the 1. So this gets closer to e, but then it gets raised to the negative 1. So that's the answer, e to the negative 1. So if you plug in bigger and bigger numbers for n into this, a million, a billion, a trillion, it gets closer and closer to e to the negative 1. Okay, what else you got to know in tonight's homework? Oh, you got to know graphs now.
Yeah. Cock. Incision.
Okay, now that we learned the number e, but guys, what did your teacher say about learning the number e last year? Why is it important that we know e?
Graph it.
Like logs.
Yeah, I know you can graph
Logs
it.
or something.
It's like
Natural.
opposite of
Yeah, I know, but why is it
the
important?
opposite of the.
Yeah, I know, you're just stating the obvious. But why is it important? Why don't we learn, why can't we just graph 2 to the x, 3 to the x, and 10 to the x? Why do we have to graph e to the x?
Interest when it's like unlimited or constant interest.
No, that's
It's
it.
just a concept.
Concentrated interest.
Continuously compounding.
Like it's how it is.
Continuously compounded
That's what I
interest.
just said.
I'm not listening to you. Okay, so let's look at the, okay, let's just, oh my gosh. Why don't we just start with this, 2 to the x. What does the graph of 2 to the x look like? We did this yesterday, right? Let's plot some key points. 0, 1, 1, 2, negative 1. Okay, so it looks like this. Now, what if I ask you to graph the inverse of this? How do you graph the inverse of this function?
Mr. Park,
Use,
why'd you put that
Why
at
equal
3?
that?
because I'm dumb, that's why. Your dumbness is contagious. There, is that better?
Yeah.
1, 2. Okay, we switch the x's and y's. Okay, here's the point 0, 1. Switch it.
0.
Here's the point 1, 2.
2, 1.
So 2, 1. Here's the point negative 1 half.
1/2.
1 half negative 1. Now, so. And can you see that they're symmetric about the line y equal x? Of course, they have to be. That's why we study inverses so that we can do this thing now. Okay, so what's the equation of this inverse? You switch the x's and y's. It's x equal 2 to the y. That's what it is. That's the equation. However, we need to solve for y. How do you solve for y? Well, you can't do it algebraically. That's why somebody invented. They said if you're going to solve for y, you're going to get this. Y equal log base 2 of x.
Wait, so
Somebody just made that up. And who are the two inventors of logarithms? Who's on Science Bowl? History Bowl. This is the kind of stuff you got to know. No, Briggs and Napier.
be fair.
Why is that funny?
I think it's not PA.
It's what?
Whatever, okay? So you guys see that? Anyway, last year, okay, so here we go. This is the inverse of that. So if somebody were to ask you what's a logarithm, what do you tell them?
It's made up.
It's the inverse of an exponential. That's what a logarithm is.
Getting into the water.
So this is called, see, both of these are exactly the same thing. This is called exponential form. This is called logarithmic form. The key to working with logarithms is you gotta be able to go back and forth between the two. Now, I'm sure your teacher told you this last year. Whenever you see log base b of a is equal to c, that means the same thing as b to the c equals a. Isn't that this right there? This is the key to working with logarithms. If you see something in logarithmic form, you just change it to exponential form. If you see it in exponential, change it to logarithmic. Easy. It's quite, logarithms are pretty easy, you know. I just don't know why students have a hard time. Maybe the first time you see it.
So,
Okay, so let's quickly. What is the graph of y equal e to the x? Doesn't it look like this? Basically, every exponential function, if this number is greater than 1, it's pretty much the same. Right? It goes through point 0, 1. So what does the inverse of that look like? Here's the point 1, 0. Wow! Symmetrical on the line y equal x. Yeah, but what's the equation of this graph? X equals e to the y. Okay, change it into log form, so this is y equals log base e of x. However, we learned last year that when the base is e, we don't write log base e, we write natural log x. Natural log x simply means log base e. Yeah.
so like, does log like have a why are you laughing? Does log
I'm
have like,
laughing. I'm bracing myself.
does log have like a number or like a formula, or is it just like a placeholder? Like,
No, I'm laughing.
no, like,
A placeholder.
like, I don't know, like, is it like a formula or like what is it? Like, I don't. Okay, so like, let's say your calculator function is graphing, okay? Which one does it use?
Uses the one that you punch in.
Yeah, but like if I type in like log b of a equals 0, does it like,
Okay, if you want to graph this on your calculator, this is what you do. You go y1 equal natural log x.
yeah, but I'm trying to like understand like what is the natural log? Like,
It's the inverse of e to the x.
so then like when it's graphing it, it would use the other one, the other equation.
No,
Like,
this is a known function. It's the inverse of that.
like what I'm saying though is like, could you solve y equals ln to the x by hand without switching back to the other form?
Okay, wait. Y equal natural log
Okay,
x.
like say
Solve for what though?
like say x is 2, okay?
What?
Say x is 2, so y equals ln 2. Could
Okay, y. Okay, first of all, natural log 2 is a number.
yeah.
That number is, you guys know in chemistry, is 0.693, right?
Yeah.
It comes up in half-lives and stuff, right?
Yeah, so like
It's a number.
But like,
Okay, wait, maybe if we go finish the lecture. Oh boy. Okay, now we also learned last year, log base 10 of x. When the base is 10, we don't write log base 10. What do we write?
Log.
We just write log x. So if you see log x and there's no base here, that means it's assumed to be 10. We call this a common log. This is called a natural log. But from this day forward, we're just going to do all natural log. Everything's going to be natural log. Because when you go to calculus, and that's when you're going to discover why E is so important, is just leave it at that. Wait till you get to calculus. But starting from today, everything you do is natural log. That's why if you look at my answers on the bottom, everything is natural log, even though you can use other models. Okay, now, so what do you have to do tonight? You got to be able to work with logarithms. Okay, so let's start off easy. What is log base 2 of 8? Let's go back to elementary school. Okay, when you see this, okay, let's call this box. 3. Yeah, okay, some of you got it.
how do you know it?
Okay, if you have logarithmic form, you change it to exponential form. This means the same thing as 2 to the what equals 8, right? 3. Which is 3. But hopefully you can do that in your head. You don't have to keep writing that down.
So, okay, can I ask a question?
Okay, go.
Okay, so log is just like telling you to switch it to that form.
Yeah, because it's the inverse.
So it's not like any number or.
No, a log is a function. It's a
Okay.
function.
Okay. So it just tells you to
Take
switch.
that.
Log base 3 of 81. So when you see this, you
Three,
should be thinking
four.
3
Four.
to the what power equals 81. Easy. Oh, you guys think you're good? Okay, okay. Log base 8 of 4.
Negative.
8
Oh,
to the what power
Two-thirds.
is 4. It's 2/3.
How?
Okay,
I mean, I
Eight.
hate saying how, it's just kind of.
8 to the what? Okay, if you can't do that in your head, this is what you gotta do. 8 to the what power equals 4. Ooh, they have the same base. So this is 2 to the third. This is 2 to the second. Multiply the exponents. And if 2 to the gorilla equals 2 to the banana, gorilla equals banana, so x equals 2/3. But hopefully you can do that in your head though. No? Okay, here, this is how I do it in my head. Okay, how do I get from 8 to 4? They both have a common base of 2, so how do I get from 8 to 2? You cube root it, which is 1/3 power, right? And then once I'm at 2, what do I have to do to 2 to get 4? You square it, so then you multiply the exponents to get 2/3.
Well, can you just square it?
I've been doing math for like years. It's simple.
Okay, let's do another one. Log base 81 of 27. So 81
Nine.
to the what power equals 27. Okay, what's the common base?
No.
3. How do you get from 81 to 3? You got a fourth rooted, which is 1/4 power, right? And then how do I get from 3 up to 27?
Three.
You cube root it, you cube it, so that's why you get 3/4.
Come on, give us a challenge.
You get, you think you're good? You think you're good? Log base
94.
No, 64 of 1/512.
2. The base is 2.
Okay, the common base is 2. How do I get from 64 down to 2?
6.
You sixth root it.
Then negative.
And then how do you get from 2 to
Tell
512?
me.
Negative.
You ninth power it.
Negative.
Because I keep telling you guys 2 to the 10th is 1024, but you guys don't want to remember it. Negative.
Negative.
But since it's 1 over, you negatize it, so negative 3 out is the answer.
Oh, why didn't you just go with the 2?
I don't know. Flustered is left. Yes.
For the first one, the 2 was negative. Did it have like no solution?
No, cannot.
Okay.
Cannot. Remember, in an exponential function, this number gotta be bigger than, gotta be positive, and it can't be 1. So since it's the inverse, this number here has to be greater than 0, but it cannot be 1. So it can't be negative. Okay, now, since an exponential function, let's just say b to the x, it can be any base that's y, and log base v of x. What's the relationship between these two?
Inverse.
They're inverses of each other. And what did we learn about inverses when we study functions? If two functions are inverses of each other, what happens when I plug one into the other? X. The answer comes out to x. So if I take this and plug it in here, that's x. And if I take that and plug it into here, x. Yeah, these are all the things that were written in your book last year. And these two things comes from the fact that they're inverses of each other. So, what if I give you this problem? What is 7 to the log base 7 of 3? 3. Because they're
Because the
inverses of each other. Because they're inverses. Because 7 to the x and log base 7x are inverses. You guys get it? I don't know. What is e to the natural log 2? 2. What is 10 to the log of 5?
5.
5. It's the same example. Go there, you don't write it down. They're like this is base is equal, you don't write it e. Do you like it when the voice gets high? That means the blood pressure is going up.
Why would you put Ellen?
No, I'm just writing for him. You know, you don't write ln base e. I'm just saying ln means base e.
You change the log.
Load.
Okay, tonight's homework, you don't have to know anything about the laws of logarithms, okay? That's Monday's lecture. And that's the last thing we're learning, is the laws of logarithms. Okay, so tonight, I believe you're gonna have to draw graphs. Okay, so let's just be clear about it. Just the two graphs that you are responsible for are these, which is gonna be on the next quiz. Okay? Now this is all I care about. When you graph y equal e to the x, you just plot the point 0, 1 and just go. When you graph y equal natural log x, you just plot the point 1, 0 and you go. And then you gotta do stuff to it. Okay, let's just do one example.
Oh wait, this,
I hope it's not the same as the homework, but it doesn't matter. Graph me y equal negative e to the negative x
you flip it.
plus 1.
Oh,
Wow.
changed it.
I had it.
Okay, so the first thing you should do is draw the base graph. Here's the point 0, 1. Okay, what does this do to the graph?
Flip.
It reflects it over the
Why?
y-axis. So, what does that do to the graph?
Over the
It
X.
reflects it over the x-axis. So you got. And then what does that do to the graph?
Move it up
No,
one.
1 up, 1 up. So this point goes up here. The horizontal asymptote is now at y equal 1 instead of the x-axis. So you got a label. So now the graph will take this. Live action. That's the kind of stuff you're gonna have to do on tonight's homework. You're gonna take the base graph and then you're gonna do stuff to it. Okay, I'm gonna give you a hint because this is gonna be on the next quiz. How many times am I gonna give you that before? So you take the base graph, which is natural log x, this one right here, and then what are you gonna do to that? I keep. Okay, this is the same thing as negative x plus 2. There's two things going on. You reflect it over the y-axis, and then you shift it 2 to the left. But which one do you do first?
Shift.
You shift it 2 to the left first, and then you reflect it over the y. Because remember, 2/3 of you got it wrong on the quiz, the test function, even though we did it several times. You're gonna get it on tonight's homework, plus you're gonna get it on the quiz too. Yeah, look at E. And then please check your graphs on your graphic calculator. The bell's gonna ring already. I thought we were gonna finish like 10 minutes early.
Wait, so do we use
Oh, because you asked all those questions. They were good questions.
This is part.
You don't need to, I define it for you. I define it. You don't. Yeah, okay. He said, Mr. Park, how do I graph cosh? Well, it says, next to it, I give you the definition of what hyperbolic cosine function is. I don't know if you know this, but you actually have cosh on your calculator here. Look in the catalog, it's all there.
And I do 14. And so 1.
I've been pushing down this whole time.
I give up. Yeah, your calculator it's gonna have trouble once the numbers get too small.
Hey, Mr. Park, don't get stressed. Reliever.
You gotta get him a squeeze ball.
Get into your palm.
Yeah.
Who do you think you're dealing with here? You're dealing with a child?
We have homework last night for physics.
Is it really?